Okay. So you might, you might wonder about some of how they call these equations. Like, what's the difference between two-step and multi-step, or multi-step and equations on both sides? I mean, if you got variables on both sides, then isn't that going to be a multi-step? Yeah, it is. It is. Some of these things, how you define them, maybe their definitions kind of overlap. But exactly what they're talking about here, again, we did this one in the homework last night, right? That two-step means literally -3 divided by 2, right? 2 clean kind of steps like that. What they mean by multi-step, which does not involve having variables on both sides, means you're going to have some combining of like terms to do on one side of the equal sign, right? And then it'll be a two-step equation, right? If it's equations with variables on both sides, then literally it will have variables on both sides. And something like this is the most simple example of that. I mean, you could have to combine variables on one side before you start moving variables side to side. This one doesn't have that. There's no like terms, no like terms. So what we're doing today are these two. We did that one in the homework last night. So this is very multi-step. What are the like terms that I need to combine? The 11m and the -6m, okay? What makes them like terms? Same variable raised to the same power. How do you combine like terms? You combine the coefficients, right? So that's 11 minus 6 times m, which is, right, 11 minus 6 times m. So that's 5m minus 8 equals 22, right? Now, once you've done that, you've got the two-step. I mean, that becomes a kind of a question like we did in the homework last night. I think I'm going to, just tell me, what are the two steps that I would take here to isolate the m? Add 8, divide by 5, okay? What are the like terms I have to combine on this one? Negative 2y plus 5y. What is that? Asia. Negative 2y plus 5y. Negative 2 plus 5. Three y. Right? It's like 5 minus 2. 3y plus 5. Okay, now it's a two-step. What are the two steps you're going to have to take to solve that? Right, subtract 5, divide by 3. Okay, so these multi-step just means you're going to have to combine some like terms before you can get to what we already did in the homework. And just because this is taking longer than I thought, we got a lot of slides, I'm not going to take those last steps. I'll go for some of them. What about this one? What do I have to do to simplify this one? Yeah, you're going to have to use distributive property first on the left. So what is your next line going to look like? What is the negative 8 times 2x? Negative 16x. How about negative 8 times negative 1? That's a plus, right? Negative times negative makes plus. Okay, now it's a two-step equation. Let's finish this one. What should I do next? Subtract 8. Negative 16x equals 28. And then what? Divide by negative 16, right? Because it's a negative. So divide by negative 16. So x equals negative 28 over 16. Now, could we simplify that? What's the common factor between 28, the greatest common factor between 28 and 16? 4. So if you knock out a 4, right, that goes in 7 times, it goes into that 4 times. So that's negative 7/4. Does it matter that as I wrote that, Here, the negative 16 was, the negative was clearly on the 16. Here, I just put it in front of the fraction. Here, it almost looks like it's on the 7. Does it matter to the value of the fraction? No. In any case, it's a negative 7/4. So what am I going to have to do to this to turn it into a two-stepper? Another distribute, right? 18 equals 6x minus 18. And then what two steps would you take? Add 18, divide by 6. Okay, now this is a special kind of problem now. Are those like terms? Is 3x over 4 a like term with x over 3? Do they have the same variables? Are they raised to the same powers? Yes. So those are like terms. Now, to combine like terms, you're going to have to add fractions. I mean, this is literally 3/4 x minus 1/3 x. So in order to add or subtract them, we're going to have to add or subtract the fractions, which means you need a common denominator, right? So the common denominator will be 12. Now, instead of doing it exactly like that, can I pass? Normally what you do if you're solving an equation like this is you don't add the fractions like that. Instead, if you identify what the least common denominator is, multiply both sides of the equation by that least common denominator, right? So in this case, the least common denominator is 12. So multiply both sides, every term, by 12. And I'm going to show it like this. Right? Multiply the whole thing by 12, which is going to look like this. 12 times 3x over 4 minus 12 times x over 3 equals 12 times 10. Now, if you notice, the 4 in the denominator here actually divides evenly into 12. So you can cancel the denominator. And the same thing here, the 3 divides evenly into 12. Well, it should, because the 12 was the least common denominator for both of them. So I can simplify this by doing that. Cancel the denominators. And now this thing is 3 times 3x, which is 9x, minus 4x equals 120. So you don't have to deal with fractions. We don't really want to have to add or subtract fractions. So instead, multiply by something that will get rid of the denominators, and then you don't have to deal with fractions. Right? Now this becomes 9x minus 4x is 9x minus 4x, 5x. This is a lot easier to solve than with the denominators in there. And then divide by 5. What's 120 divided by 5? How many times does 5 go into 12? 2. And then 2's left over. How many times does 5 go into 20? 4, 24. I mean, if you have to, you could set it up like a 120 divided by 5, like that. So if you have denominators, you want to think of, find the least common denominator and then multiply both sides, every term, by the least common denominator, because it will cancel all the denominators. And then you don't have to deal with fractions. Right? What is the least common denominator between 5 and 4? 20, right? So identify it. LCD is 20. And then multiply everything by 20. 20, 20, 20. And now cancel the denominators. 5 goes into 20 how many times? 4 times. 4 goes into 20 5 times. So here's our updated equation, which does not have denominators anymore. 4 times 2b, 8b, 5 times 3b, 15b, 3 times 20, 60. Remember, if you do this, you've got to multiply every term by that least common denominator. Don't forget one term on the left, or especially the mistake most of the time is we just don't do the right-hand side. But you got to do everything by that. So this is 13, oh, sorry, can't add myself. 23b equals 60. So b equals 60 over 23. Can that be simplified? Can you think of any factors of 23? What do you call a number that doesn't have any factors except for itself and 1? It's prime. It's a prime number, so there's no factors of 23. So they're not going to be any in common with 60. Well, you know, if 60 had a factor of 23, like if it was 46 or something like that, then it might have worked. So remember, if you've got fractions, multiply through to get rid of. That's called clearing fractions. Clearing fractions. Now we got 3 denominators. What's the least common denominator between 9, 6, and 3? What is the smallest number that all 3 of those divide into? Now, what is the lowest number that 9 divides into, 6 divides? Not the lowest number that divides into all of those. 18. Right? Don't think of it like what's the common factor between all of those. That's not what we're asking. We're asking what's the number that all 3 of those divide into? 18. So you say if the LCD is 18, you multiply by 18 times 18 times 18. Right? We're not doing 18 over 18. Right? We're not doing that. Because since it's an equation and we can balance out by multiplying on both sides, we don't need to make it multiplying times 1. Right? That's the difference since it's an equation. Now, the 9 goes into 18 2 times. The 6 goes into 18 3 times. And the 3 goes into 18 6 times. Right, so what's left is 2 times 1, 5 times 3, and negative m times 6 minus 6m. And that's a 2-step equation. What are the 2 steps that I would take to solve? Subtract 15, divide by negative 6. Okay, decimals. We have a similar thing that we can do for decimals. When you have one place to the right of the decimal point, then what does that number represent as a fraction? It's a tenth. Right? These are the tenths place. That's 5 tenths. If you have 2 places to the right of the decimal, then that second place is hundredths. So what we need to do in this one, we need to move the decimal place over twice. What could I multiply by that will move the decimal place over twice? By 100. So it's kind of like clearing fractions. We're going to multiply by 100. And that'll move the decimal place over twice. When you multiply this one, but move it over twice, you get 350. Right? This one, you move a decimal place over twice, you're going to get minus 2x. This one, what do you get if you multiply 1.24 times 100? 124, right? It moves it over twice. 124. So, I mean, in a way, you can think of that like clearing fractions, because decimals are fractions. Okay, what are the 2 steps I would take to solve that? Subtract 350 and divide by negative 2, right? 2 steps. But remember this step here, right? Okay, now we get into where we have variables on both sides. Before you start to move things around from side to side, you should make sure there's no combining of like terms to do on the same side. Is there anything that we could combine between 5x and 2? Are they like terms? No, because one has an x and one doesn't. And the same thing over here. So make sure there's no combining of like terms to do, right? And then we need to get all the x's on one side, all the constants on the other. Usually, you don't have to do it this way, but usually you move variable terms first. And the one you move is the smaller of the two. So if you're going to look 5x and 2x, you say to yourself, which is smaller, 5x or 2x? The 2x. So move that one. Okay, how can we cancel a positive 2x on the right-hand side? Subtract 2x. Right, that's a plus 2x, so we subtract 2x. 5x minus 2x, 3x. 2x's cancel, 14. Okay, now it's a two-step equation. Subtract 2. 3x equals 12. X equals 4. Okay, is any combining of like terms to do on this one before we start moving things side to side? The question was, is there any like terms on the left? Any on the right? So we can start moving. Which term are we going to move first? The smaller of the two variable terms, which is 4k. How do I cancel a 4k on the right? Subtract it. So that's 3k plus 2 equals negative 10. And from there, two-step equation. So remember, combine like terms on the same side, and then move the smaller of the variable terms as a first step. How about this one? What do we need to do to simplify that? Yeah, you get distributive on both sides. Okay, now it's like the last problem. There's no like terms to do on the same side, and so you could start moving side to side. Which is the term you would move first? Right, the smaller of the two variable terms is 3x, so subtract 3x. Seven x minus 2 equals 33. 7x equals 35. X equals 5. How can you be sure if that's right? You could check it by plugging it in and seeing if it works. Okay, what would I do in this one? Distribute, right? So that'll be 8y plus 4 equals 2y minus 26. Which term to move first? The 2y. Subtract 2y. 6y plus 4 equals negative 26. Okay, is there, and at that point it's a two-step equation. What two steps are you going to take? Hello? Can I help you? Uh-huh. Sure. Okay. You send it back there. Okay. So what are the two steps we're going to use to solve this? Subtract 4, divide 6. Okay, now we only have distributive property on one side. So just do the one side. 10x plus 12 equals 10x plus 12. Okay, oh my gosh, what's going to happen here? Which term would you suggest we move first? I mean, both the variable terms are the same, right? So one is not smaller than the other. So let's say we subtract 10x from both sides, right? Now we have 12 equals 12. Well, notice that in that one step, we eliminated the x's. There are no more x's, right? When that happens, that means that your answer does not depend on the value of x. It's either always true or always false. If you look at that right there, is that a true statement? Does 12 equal 12? It's true. So since what we are left with is a true statement, then you're going to say it's always true. It has to always be true or always be false. Since that's true, then it's always true. And when an equation like that is always true, it's called identity. Right? When it's true for all values of the variable, then you call it an identity. Most of the time, when we solve an equation, we get a value for x. That's called a conditional. It's true on the condition that x equals a value. When it's always true, then it is identity. Right? How about this one? Now this is the first one we've seen, which has variables on both sides, but it also has some combining of like terms to do on the same side. What terms do I need to combine first? Right? These two on the same side, I need to do. Now, common mistake that I see is that you're gonna try to move this by saying add 3m, add 3m. Okay, that's not correct. You just added 3m twice on the same side of the equal sign. Right? So don't think of it like you're solving the equation by moving terms side to side. Instead, combine like terms like we always combine terms. What's negative 3m plus 12m? 9m plus 5. And on this side, we've got 9m minus 4. Okay, move the variable term. What should I do? I mean, they're both the same. So what's going to happen when I subtract 9m from both sides? They're going to cancel each other. They cancel on both sides. And what we're left with is negative 4 equals 5. Again, like the last one, there's no variable. So the answer to this does not depend on the value of m. It's either always true or always false. Is that true or false? It's false, so it's always false. Right? Since negative 4 does not equal 5, right? That means no solution. Right? If that's a false statement, then there's no value you could plug in for the variable that would make that any different. Okay, so that was the next step in our solving of things. Multi-step, which means you're going to have to do something on one side, combine like terms, before you do two steps to finish. And then equations with variables on both sides, which you're going to have to learn how is it that you move all the variable terms to one side. Right? Usually, move the smaller of the two. Usually. Okay. So the homework is going to be, that comes from two different sections, and it's like 2 or 3 problems from each one of these groups. You know, you'd probably, if you take your workbook, if you have your workbook, just circle those numbers so that you know which ones you're supposed to do. And we are going to do a timed multiplication test, and it's going to be 4 minutes. So go ahead and write those down, and then we're going to start on that.